This is probability jeopardy. The answers are 2 over pi, 1 over e, and 1 over phi.
Yeah, but what's the question? Our categories today are easy as pie, natural E, and I'm golden. For this particular segment, let's select natural E. This is something I call the Frog Princess, with sogrates and amphibianes. You will play the part of sogrates.
And amphibianes plays the part of himself.
Through painstaking research, I have traced the origin of the tale of the Frog Princess to ancient Greece. I've discovered a lost manuscript about the greatest philosopher of all time. Though long since forgotten, at one time he was so great that people called him Sogrates. This manuscript describes a dialogue between Sogrates and one of his students, Amphibianes, who was always hopping all over him with questions. Throughout the following reconstructed dialogue, notice how Sogrates employs the Socratic method, by which the student is brought to knowledge through queries such as, "What's so great about that?" Remember, you are playing the part of Sogrates, and Amphibianes is playing the part of himself. I will help you with the Sogrates part, but please speak along with me.
Oh, great sogates. I am in search of true love. I need to find my soulmate so I don't have to flounder around life on my own.
So how do you plan to find such a fish in the sea, O flycatcher?
So that I won't get all bogged down, I decided to employ an executive dating service. Now I'm in a muddle.
What is the source of such befuddlement, Tadpole?
After filling out a questionnaire with 10,000 questions and sending in a couple of fins, I was told that I would be put in touch with 100 princesses who matched my answers to the questionnaire the best. Each one has a different score, so I know that the one with the highest score is the princess of my dreams. All I need do is kiss her, and she will turn into a frog, and we will live happily ever after.
Sounds like a fairy tale to me. So do it!
Ah. But the princesses are to contact me in random order electronically over the next month or so. When a princess contacts me, all she will tell me is her score. Then I either accept her invitation for a kiss or pass, allowing her to move on in search of another amphibian. If I do not accept her invitation, I can never contact her again. What do I do?
Don't flip out. Just wait till you get contacted by the princess with the highest score.
That is my problem. I don't know what the highest score is. I just know that they are all different. Since there must be a highest score, I am sure that my soulmate is one of the 100 princesses. I just need to figure out how many to let slip by before I take my chances. Help me, oh Socrates, please, 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 please.
Okay, Lilyhopper, let us suppose that you determine the magic proportion, P, of princesses that you let slip by. Then how would you proceed?
Simple. After I let that proportion slip by, I would wait till a princess contacts me who has a higher score than all the princesses I have passed on.
Yes, but if second best occurs after P and before your soulmate, won't you have settled for second best? Let's pause and make sure we understand the problem. If we only had 3 princesses, how many possible distributions would there be? Enumerate them. Write them out. You should have something that looks kind of like this. 6 possibilities. Suppose we always take the first contact. Well, this isn't hard because we get our soulmate the first 2, but the other 4 possibilities we don't. Suppose we always pass on the first contact and take the next one that is better than all we've done so far. Try it out, see what you get. Pause the video if you need to. Clearly, in the first case, if you pass on the first contact, you never get anything better, so you end up with the third. The same thing happens in the second scenario. In the third scenario, you pass on 2, one is better, so you accept that. In the fourth scenario, something similar. You pass on 2. 3's not better, so you don't take that, and you end up with 1 because that's the last choice you have. In the fifth scenario, you pass on 3. 1's better, so you take that. And if you look at the last scenario, you pass on 3. 2's better, so you select that. Counting them up, you will see that you get 1 half the time, so it's 50%. Suppose we always pass on the first 2. It's similar than passing on, or than taking the first contact. You end up with 1/3 of the time getting your soulmate. If we now have 4 princesses, how many possible distributions will there be? Again, pause the video. It actually turns out that there are 24. If you think about it, the 4th princess in each one of the previous distributions can be distributed in 4 different ways: in the front, in the back, or somewhere in the middle. Suppose we always pass on the first contact and take the one that is better than all we've seen so far. So we'll kind of do this by columns. Look at the first column, see what happens. You should get a result like this. Second column, you can't lose. You always get your soulmate. Third column, notice you get your soulmate half the time because you're basically comparing to 3. And in the last column, you get your soulmate 2 out of the 6 because basically you're comparing to 4, so everything's better when you go to the next one. Note, of course, we could consider the 2 trivial cases again, or we could pass on the first 2 contacts and take the next one that is better than all the one we've seen so far, which actually results in 1 less win than we have above.
Exactly. Now you see my problem. I know I can't guarantee that I will select my soulmate, but I want to figure the magic proportion P, which gives me the best chance. I even contacted the dating service and asked them to include more princesses in my pool. They will allow me unlimited princesses. I know that sounds a tad politically incorrect, but what can I do?
Well, you actually need calculus.
Small stones or tooth deposits?
Neither. Something that will be invented by Newton and Leibniz in the future.
And what would calculus say?
I could tell you, but you wouldn't understand.
Try me.
For simplicity, I'll just say that the overall probability that you find your soulmate, SM, is SM of P, which is equal to the opposite of P, ln P, where P is the proportion that you let slip by before you make a selection using your method. Now, all we have to do is maximize SM of P.
You're right.
Of course.
No, I mean you're right that I don't understand calculus. What is an ln?
A natural log.
A log, naturally. I can get into that. Now, how do I maximize SM of P is equal to opposite of P, ln P?
We could use your TI or calculus again.
Naturally. Okay, hit me with the calculus. Not a small stone, though.
The derivative of SM of P is equal to opposite P times 1 over P plus the opposite of ln P by the derivative product rule.
Naturally.
Now set this equal to 0 and solve.
Well, since -1 equals ln P, then P equals 1 over E.
Natural E.
No, reciprocal E.
Yes, but why the factorial, oh bug-eyed one?
I just got excited. And without calculus on my TIBC, I also get about 0.3678 when I try to find the maximum of the graph y equals opposite x ln x. Wow, since 1 over e is about 0.3678, I should pass on about 37%, no matter how many princesses there are. And since I see that the x and y coordinates are the same, that is also the probability that I'll find my soulmate. Oh, thank you, Sogrates. Now I have a good chance of finding my soulmate. But doing all of this math reminds me that true joy is found in mathematics, not random relationships. I'm going to stick with Miss Piggy. I just have to wait till she recovers.
Recovers? From what?
Swine flu.
And that's the true story of the Frog Princess. Honest. Isn't that a cool result? Results like that make me want to sing. This is a song about the number we call E. There's a number, a special number, we use it constantly. There's a number, a special number, we use it constantly. 2.718. 2.718. For logarithms, yes, logarithms, the base is naturally. For logarithms, yes, logarithms, the base is naturally 2.718. 2.718. To compound interest, continuous interest, it's pert shampoo for me. To compound interest, continuous interest, it's pert shampoo for me. 2.718. Me. 2.718. That was another story from Math Camp. If you would like to hear the other 2 stories involving probability jeopardy, come back and visit Math Camp again.